Section 2.2 Derivative as a function. Example 2. The graph of the function is shown below. So this is a graph of function f. As you can see, it's continuous over the interval 0 to 6. We want to identify the graph of its derivative. What it means is just draw the graph of its derivative f prime. So f and f prime, the relationship is that f prime is a slope of f. So we want to find the slope. Now, for the first part, we have a positive slope. And then for the second part, it's a horizontal line. So it's easy, right? From 3 to 6, a horizontal line has a slope 0. So from 3 to 6, the derivative is 0. Constantly, okay? So this is easy, but what about this part, okay, that has a positive slope? So we need to find out rise over run, right? From 0 to 1, 1 unit change in x, and the change in y is from 0 to 2. So rise 2 over 1, run is 1. So the slope of the first line is 2. So from 0 to 3, the slope is 2. Now how about at 3 itself, okay, at the point 3 right here. So now you need to think about limit, right, or the derivative. So limit as x approach 3 from the left, okay, right here, approaching 3 from the left, f of x has a slope of 2. But limit as x approach 3 from the right, so number that are bigger than 3, f of x, it has a slope of 0, okay, because it's a horizontal line. Because these two left side limit and the right side limit does not equal, so the limit does not exist, and we put a hole right here. Section 2.2, the derivative as a function. Example 2. The graph of the function is shown below. So this continuous function is your f. We want to identify the graph of its derivative, meaning just draw the derivative f prime. So the first, we can take a look over the interval 0 to 6. F is like a piecewise function. The first piece has a positive slope, and the second piece has a horizontal line. A horizontal line has slope 0. So it's easy to find out from 3 to 6, the slope is 0. Now from 0 to 3, okay, it's a straight line, so the slope is also constant, okay? Constantly increasing. But what is the slope? So we will find out rise. Okay, so 1 unit change in x account for 2 unit change in y. Okay, so rise is 2, run is 1, rise over run is 2. Okay, so from 0 to 3, it has a constant slope of 2. But what about at this point 3? Okay, so from the left of 3, limit as x approach 3 from the left. What is the slope? The slope, okay, going this way. And we're talking about the slope, not the function value. The slope right here is 2. Okay, so m equals 2. What about on the right? Okay, so when limit as x approach 3 from the right, the slope is 0. Okay, slope of the horizontal line is 0. Because the left limit does not equal the right limit. This limit doesn't exist. So what it means is at 3, the function is not differentiable. So it's a hole in the derivative f prime. Now, what it means is that whenever you see a sharp corner, a sharp turn, the function is not differentiable at that point.